In this vector, I is a unit vector horizontally and j is a unit vector vertically. A particle of mass of 0.2 kilograms is acted on by its weight, and the force is given by 6I plus 5j newtons and pi plus 7j newtons. Write down the value of p if the acceleration is vertically upwards. If the initial velocity is 20I minus 30j meters per second, find the velocity 5 seconds later. So what we're going to do here is we're going to try and find the acceleration using Newton's second law, and then use one of the Suvat equations to find the velocity after 5 seconds. So as the acceleration is in the j direction, i.e. the acceleration is vertically upwards, then the resultant of the I component must be 0. So if we take the I components, we've got 6 plus p. There's no I component of the weight, so 6 plus p must be equal to 0, therefore p must be equal to minus 6. So if we now try to draw a diagram of the situation, so there's my particle, which has a weight of 0.2 kilograms. And what forces are acting on it? Well, we have the weight acting downwards, and so the weight will be 0.2 gj, and then we've got the other two forces. We've got one going off here, 6 along 5 up, which is 6I plus 5j. This is not drawn to scale, this diagram, it's just a rough diagram. And now, because we know that p is minus 6, we now have another force going minus 6, 7 up, going in that direction. And we have an acceleration which is just going to be vertically upwards, okay, because these two components cancel each other out, and there is no I component here. Right, so now using Newton's second law, we're going to have minus 6I plus 7j, this force, plus this force, which is 6I plus 5j, minus the weight, which is acting vertically downwards, which is 0.2 gj, is going to be equal to ma, mass times acceleration. So the mass is 0.2 times the acceleration that we're trying to find. Now, these are all vector quantities. Force is a vector quantity, and acceleration is a vector quantity. Mass is a scalar quantity. Right, so simplifying this, minus 6 plus 6 comes out, and then we're going to have 7 plus 5 minus 0.2 times 9.8 will give me 10.04 j is equal to 0.a, and therefore a will be equal to 10.04 divided by 0.2, which is 50.2 j. Okay, so now using V is equal to U plus AT, V, U, and A, all vector quantities. U was given in the question as 20I minus 30J. Then the velocity after 5 seconds is going to be equal to V, which is the initial velocity, 20I minus 30J, plus the acceleration that we just calculated, which is 50.2J, times the time, which is 5. So that gives me 20I minus 30j, and then 50.2 times 5 gives me 251j. And therefore, adding the respective components, this is 20I, then minus 30 plus 251 is going to give me 221j meters per second. So this has been a video to show you how to find the velocity of a particle moving vertically upwards. I hope using vectors. I hope you've understood, and I thank you very much for watching.